Algebra 2, we're going to take a look at how you find tangent without your calculator using the unit circle. So one thing that we have to know about tangent is something that we talked about back in geometry. So there's an acronym back in geometry, SOHCAHTOA. TOA was the part reserved for the tangent. TOA stands for that your tangent ratio is the opposite leg over the adjacent leg. So that's a little acronym. The O and the A are standing for opposite and, oops, forgot the D in there, adjacent. So when we started looking at our unit circle, the unit circle is made up of different special right triangles, 30, 60, 90s, and 45, 45, 90s. Like if we zoom into this first 30, 60, 90, there's the radius of our circle. There would be the y coordinate, which is the short leg, which ends up being 1/2. There would be the x-coordinate, the long leg, which ends up being the square root of 3/2. Now, when we're looking at this triangle, we've got our angle right in here. That's where that 30 degrees is. So that we're going to call theta. So theta is right there. And then when you're labeling your right triangle, you label it based on where your angle lies. So our angle lies right here. That makes this the opposite side. And makes this the adjacent side. Well, what do those two sides really represent? When we found these coordinates using our unit circle and using our special right triangles, the opposite leg really represents the y coordinate. This adjacent leg is represented by this x coordinate. Now going up above, the tangent then of theta is equal to your y coordinate over your x coordinate. So that's what we're going to use in Algebra 2 to calculate the tangent using our unit circle. You also see as you get into pre-calc and calculus, the tangent of theta is equal to the sine of theta over the cosine of theta. And sine of theta, we've discussed in section 1 that is your y coordinate. Cosine of theta, that is your x coordinate. So heading back to our first problem, we want to find out what is the tangent of pi. So to do that, we are going to go and locate on our unit circle where is pi, and you'll find it right over here. There's where pi is located. Then I look at what are the x and the y coordinates of that position of pi. And there they are. X is -1, y is 0. To find the tangent of pi, I'm going to put it below the problem. Then you take the y coordinate over the x coordinate. 0 divided by anything is still going to be 0. So the tangent of pi is going to be equal to 0. And I would recommend as you continue to fill in your unit circle, you go around this outside and start filling in all the tangents. So maybe you have a different color, a different style of pen or pencil or marker that you could use to signify what those tangents are. So tangent is 0 right there. Let's go to 3 pi over 4. We'll do 3 pi over 4 in purple. 3 pi over 4 is right here. And I locate what's the x coordinate and the y coordinate. And to find then the tangent, you take the y coordinate over the x. So this will be square root of 2/2 in a fraction with the negative square root of 2/2. Now here we get a complex fraction like we saw in chapter 8. So we're going to rewrite this as division, which really, when you're dividing fractions, is multiplying by the reciprocal. So we're going to take the numerator, rewrite it as square root of 2/2, times the reciprocal of the denominator, which is -2 over the root of 2. And you can put your negative anywhere you want. Now, when you're multiplying fractions, if you have the exact same thing in the numerator, they will reduce out with something the same in the denominator. Up here, -2 and 2 have a 2 in common. That makes -1. So multiply it all out, you're going to get -1 for your result. And up here then, we'll put the tangent is -1. And lastly, the tangent of pi over 2, we'll locate pi over 2 is right here. There's your x, there's your y. Tangent is y over x, so we take 1 over 0. Now something funky happens here. When you take and divide by 0, we found that out when we were looking at chapter 8, those points of discontinuity, it's undefined. So pi over 2, you're going to be undefined. So again, just find a spot using a different color, different marker, different style, put undefined. You'll also notice down at the bottom of your circle, you are undefined. And when we start getting those undefined positions, you'll see later on when we're graphing, if you're watching videos for numbers 4 and 6, that we will put asymptotes in those positions. So the last one that we can find is like, let's do the tangent of pi over 6, the one that we highlighted there with that special right triangle. So tangent of pi over 6 is going to be the y over the x. So y is the 1/2 over square root of 3 over 2. And I'm going to be running out of room, so we'll bring this down here. That means we're going to multiply by our denominator's reciprocal. So we're going to take 1/2 times 2 over the root of 3. And the 2's will reduce out, and we end up getting 1 over the root of 3, which you can't have a radical down your denominator. That was back from when we talked about that in chapter 6. You got to rationalize, and we'll get a square root of 3 in our numerator over 3 in our denominator. So the tangent of pi over 6 right there is going to be the square root of 3 over 3. So again, go ahead and you can fill those in. This is going to be a 1 right here. This ends up just being straight square root of 3. And you'll notice, just like the coordinates, how they reflect, like down here, you'll get a positive and a negative. So negative y, positive x. This will just be a negative square root of 3 over 3. So the same thing happens with the tangent as you reflect around. Other things about the tangent, it is going to be positive in quadrant 1, negative in quadrant 2, positive in quadrant 3 because you have a negative divided by a negative, and then negative in quadrant 4. So hopefully that helps you with number 1, and then also go ahead and fill in all your tangent values on your unit circle. Thanks for joining.